So let's say they ask you to use the definition of the derivative in order to differentiate the function. So the first thing you must do is to find g of x plus h. So this means when you see x in the function of g, you replace it with x plus h. And here we can see that our g of x plus h is already in its simplest form. So we can go ahead and state the definition of the derivative. So we know that it's the limit as h approaches 0 of g of x plus h minus g of x. And this whole thing is divided by h. So g of x plus h, it's just going to be square root x plus h plus 5. And then we say minus square root x plus 5. And this whole thing, of course, is divided by h. Then from this point, it seems like we have hit a dead end. So how do we unhit the dead end? Well, we have to rationalize the numerator. In other words, we need to get rid of the square roots in the numerator. And in order for us to do that, we need to multiply this expression by 1 so that we don't change its nature. But we define our 1 as the conjugate of the numerator divided by itself. And the word conjugate means the first term and the last term are exactly the same. The difference is the sign between them. They have to be opposite in sign. The conjugate of x plus 1 is x minus 1. So you need to know that every time when we multiply conjugates of one another, that is the numerators, we only multiply the first terms and the last terms together because the middle terms will cancel out anyway. So we still have the limit as h approaches 0. So when you say square root x plus h plus 5 times itself, well, the square roots will cancel out. So this is what you are left with. And then you say square root x plus 5 times itself, you get x plus 5. But you have to put this in bracket because negative times positive is a negative. And then what are you going to have in your denominator? Well, every time when you are rationalizing the numerator, you have to keep your denominator in its factorized form. Why? Because you are hoping to achieve things that will cancel out. So when you expand your denominator, it's going to confuse you, meaning it will both confuse you and frustrate you. Imagine. So at this point, we just distribute our negative sign. And we can see that this x and this x will cancel out. 5 and 5 will also cancel out. So we are left with h in the numerator. And this whole thing is divided by h into square root x plus h plus 5. And then we say plus square root x plus 5. So now we have achieved things that are exactly the same in the numerator and denominator. So they commit suicide. After successfully committing suicide, we are just left with the limit as h approaches 0 of 1 divided by square root x plus h plus 5. And then we say plus square root x plus 5. And then at this point, we are just going to use direct substitution. So we say, where we see h, we just substitute as 0. So we are left with square root x plus 5 plus square root x plus 5. And seeing how these are like terms, we just add the two like terms together, and then we get 2 square root x plus 5. And this is our derivative in its simplest form.